open this text from our Google search and it doesn't go open. That's why I highly recommend it to download this to your hard drive. This way you will always find it and wouldn't need to open it or anything and worry about it's being taken out. In fact, my online class that uses statistics textbook, they took out this textbook from that Google search. So those people that didn't have time for half of semester to download it now don't have the access to the textbook. But the good thing is that everybody downloaded it. So I'm just trying to give you an idea why this is important to download the free textbook, and then you can always delete it if you say, oh, I don't have enough room, I have to download something else. It doesn't take much room. It's PDF file, and you can always get rid of it at the end of semester. So anyways, last time we looked at chapter 4, section 1, right? 4.1. We saw the exponential functions. We worked with these properties of exponents, and we saw how the graphs of those functions look like with respect to each other. So these things we gonna work with more, especially with graphing. Our class is all about graphing, so we will be doing more graphing and more. And in the next section, we're gonna continue with that. So I'd like to refresh what we did a little bit last time, and then we can move on. So there are various exercises for properties of exponents. I can try one here, like say problem exercise number 19 that has, so that's the first section of the new chapter, and the page is here, page is 303, right? So when I have equation with powers, and the power 2x minus 1 is what I need to find, and on the other side it's 16, which is same as a power of 4 to the power of 2, then I can disregard basis of this so-called exponents and just make those powers equal one with another. And this way, I can actually find whatever I need to find here, and that will be letter x by adding 1 on both sides. So we're gonna get something fractional, looks like. So 2x will be equal to 3, and x will be equal to 1.5, or 3 divided by 2. So we solved this equation. Point is, get rid of the basis of these exponents. We'll work them in more details when we get to the next section. Well, the other part of the story we did is we were graphing things, and we graphed power functions such as 2 to the power of x, or 3 to the power of x, or e to the power of x, and we noticed that all of these functions, they pass through point 1 on the y-axis. So they also have a so-called horizontal asymptote, which is my x-axis. So when I graph, I should be careful. It has to be getting closer and closer to this x-axis. That's the way pretty much all the exponential functions look like if base of exponent is more than 1. So there are some formulas involved with compound interest and 4.1 that I guess you saw in the college algebra. They're pretty standard, so I don't want to get much into this right now. But what I want to do is find the mirror image to the function to the x through the mirror along the y is equal to x bisecting line. So if I try to do that, that mirror will actually switch x and y. So if you reflect x to y, then you're going to get something like x is equal to the power of y. And this is nothing else but to say that y is a logarithm. Base of logarithm is here. It's number 2. We'll put it here. To produce number x. And that's the actual definition of the logarithm. So it's another way to write the power relationship. It's just to say what power, y is a power, I have to raise base 2 to produce x. And you get this by switching basically x and y. And that's actually what the inverse functions are doing with each other. So we say that if you have function f of x, if you saw this inverse function statement before, is to the power of x, then its inverse, we'll put like a negative first power, that's called inverse, will be logarithm base is same 2 to produce letter x. So they are inverses, inverse functions, and that's what actually their graphs showing us in here, and that's what they're working hard with on that nice figure that I opened. So logarithm is inverse function. In other words, if you have something like a logarithm of base 2 of number 8 to find, what you can do is you need to get a power that you raise 2 to get 8. See, the logarithm is nothing else but the power. The logarithm here, and there's little justification, is y, and that y is exactly the power. So when I isolated that y, that happened to be a logarithm, and that's nothing else but power to raise 2 to get x. So what power should I raise 2 to get x? Wouldn't that be 3, right? 2 cubed is 8, so the logarithm is 3. See, a relationship with the logarithm and exponents. So actually, logarithm is a power. That's just not a very pleasant way, people say, to write the exponential statement. So you can practice to find some other logarithm. Let's say, what's the logarithm base 2 of number 1 is? Well, I just want to rewrite it as a power to raise my base 2 to get 1. So what is the power that I have to use to raise 2 to produce number 1? Is that 0? Isn't it? 2 to the power of 0 is equal to 1. So this logarithm is 0. So logarithms are powers. That's what we, I guess, need to know and carry out from this section. I know it takes time to get used to it, but you will have the whole weekend in front of you to actually get used to it. So I want to say that I receiving work from some people from class, and that's making me feel better and better, because if I don't have any work related to the midterm, what kind of grade can I give, right? And that's why I'm still waiting I'm patient. I can wait for you to submit me your homework if you did not do that yet. I say, Alex, I forgot. Did I submit my homework or not? Well, look at the Canvas. In the Canvas, I posted grades. The new course grade, maybe it's still the same. If it didn't change, then I didn't put anything. The same grade stays there. Midterm grade. And for the homework, if you turn it in, I put a check mark. If not, I put the cross, so you could turn it in. That's the message. Over weekend, you can still finish up or find where your homework is and send it to me. Email it to me. I will accept it. That will do nothing but give you a better grade. So check out what you get on the Canvas. If you like your course grade, some people say, Alex, I cannot open it. Well, you just need to click on it. Just be persistent clicker. Sometimes you need to click more than once. Click, and then it opens. So simple. So the point is, you can always check your grade, current grade. So I just updated it on Canvas. And make sure that you get a grade that you like. If you don't like your grade, well, send me something. Send me your homework if it's missing. Or I told you could raise your midterm. Instead of B, you can get A. Instead of C, you can get B. Just redo the whole thing and email it to me. And I know that some people definitely can raise their grades. So I'm waiting. I'm giving you the time. I'm not going to be able to give you such a luxury after the final, because after the final, I will have 1 week and then I must submit grades. So if you don't fix anything within that 1 week, well, I'll send the grades to admissions and that'd be it. I'm not going to be able to change any grades after that because I have my own deadline for this. For now, I don't have a deadline, so I don't impose it on you, but take advantage of it. Because after the final, it's not going to be that nice and relaxing. So they graph in here various logarithmic functions. Here's another pair of inverses. One of them is e to the x, and the other is logarithm that should be base e, right, of x, but people call it with 2 letters only, ln. Let's see, why do they do that? Well, I guess historically they all agreed on calling it with ln, so, well, we use ln. But it should be logarithm base e, just like here, the inverse function was a logarithm base 2 of x. That was this one, right? It was of that graph that I already closed, base 2. So basis for exponent and for logarithm, same when you have inverse functions. So ln, that's going to be very popular for us in this class. So there are some properties of logarithms that they're considering. The property is following. So let's say if you have 2 raised to the power of logarithm base 2 of x. Well, turns out this has to be letter x. So base 2 and logarithm base 2 will cancel each other out. Why is that? Well, definition of logarithm. Logarithm base 2 of x is such a power, it's a power, that I have to raise 2 to that power to produce x. That power, right? So that's always could be written without any logarithms. So 2 to that power is x. So look at what I do. I raise 2 to such a power that gives me x. That's what I got. So that's worth to think about. Or some people just memorize it. So if you deal with logarithms with base e instead of base 2, it's the same thing. So base is same, so they cancel each other out and you get x out. But it's called not logarithm base e, but ln. So you can say e to the power of ln is the same as x. And that's what they have here as a property. And that's good to realize. And say, what does this mean? Well, that's domain of function logarithm. Look at the graph. You see that x can only be positive because this is the asymptote. Remember, it's an asymptote, so it doesn't touch that line. It's just positive. So x is always positive, never equal to 0, strictly positive. That's what they show here. Okay, so we can see this from the graph. Or you can try to use the definition that logarithm is actual power, so you could try to justify that using the ideas of powers. You don't have to, but I think it's good if you can see this at least once, because again, graphing will be something that we're going to do in later sections of this chapter. And we're actually doing it right now. We're graphing various new functions called logarithms, right? So let's just do some problems here. I'm going to move to the end of the section, exercises. So let us see what's in here. So do a few problems for practice. Looks like there are quite a few. So how about if I try the exercise number 11. So logarithm base 3 of 10. I think it's not really a good idea to start with it because I need logarithmic rules. I need to talk a little bit more about logarithms. So let me leave it for now. Let me do number 3 first. So ln of e cube. Turns out that logarithm, let me go with base 2. I think it's more intuitively. So if you have logarithm base 2 and the power is same, the base for logarithm, base for the power, same, so x will stay. Why again? Well, because what you can do is try to rewrite this once again with the losing this logarithm sign. So remember, the logarithm is a power. So this whole thing is a power. What power? Well, I have to take base 2, the one that on the bottom, raised to such a power to produce the number that sits here, this whole thing. And this whole thing is 2 to the x. So what is the power to raise 2 to get 2 raised to the power of x? Well, of course, it's going to be x, right? Because how else I can produce this 2 to the x? So that's actually one of the properties of logarithms. So if I use the same exact idea for exercise 3 and write this as not ln, but logarithm base e of e to the power of 3, analogously, since bases are the same, just 3 will be in here. And we have this result. And similarly, for the exercise number 4, when I have ln, or I'm going to say logarithm base e of e to the power of 1/2. Notice when I put logarithm base e, it's getting a little bit more clear because base for the logarithm and for exponent will be the same. So just the power stays. So it's a half. In fact, I want to show you how you can use a calculator. I know some people will use it, so it'd be fair that I go to the, oh, look at this. Eventually it opened, Remember, I was trying to open this link to the textbook at the beginning of class and I couldn't. It took a while. So now it's open. So it's still there. But advice is, if you did not download it, do this, because I don't like the way it works right now. It seemed to be kind of having a hard time. So that's why it's better to download it, because I opened this textbook from my hard drive, because that's where I have it downloaded. So anyways, scientific calculator, I select my favorite. And what I'm gonna do is enter, first of all, I wanna clean this stuff, is right on my way. Very nice, so let me get rid of this. So I'm gonna enter that ln, whatever we had, an original exercise. Like I said, I don't remember what we had. It was ln of square root of e. And that's what we actually just solved. So just go ahead and then enter it. The thing is that ln you can enter. Logarithm base 2 you cannot. In some calculators, yes, you can, but not in the standard scientific calculators. So anyways, you don't see ln here, so you need to go to functions, and that's where you're gonna be able to find it. It's right there. So you go ln, and then you need to have a square root of e. So square root is right here also. Notice that they're all here. Square root is also here in the functional menu. So put a square root, and now I need to enter letter E, and look at this. Letter E is here as well. Next to it, its little friend, number pi. So E is also the number. So I'm gonna put square root of, see, I need to click so I put it in the right place. So if I get rid of that, I get 0.5. So technically this could be calculator exercise. Again, if you're dealing with ln, if you're dealing with logarithm base e. That's why this is so popular, because every calculator has ln, but you're not going to be able to enter any other bases but base e. And that's why we want to convert this to every logarithm. We want to convert to that favorite base e. So where's my here? So if I take exercise number 11, it turns out I can write this. Let me write it separate. Logarithm base 3 of 100, such as a quotient of ln of 100 over ln of 3. This is so-called change of base formula. We changed base 3 of the logarithm to the one that we can put in the calculator to base e. Well, what permits me to do this? Turns out you could do some of the manipulations in here. So you can rewrite this logarithm base 3 of 100 without the logarithm. So I can, for convenience, use some letter, let's say x. So I can say 3 to the power of x, because logarithm is a power of base 3 is equal to 100. So that will be the first step. Next step will be to apply ln's on both sides. So if you take same thing on both sides of your equation is still the same. So you can apply, let's say, ln. It's not going to change. And now there is a special rule called power rule for the logarithms that will bring this in front. So it'll be x times ln of 3 is equal to ln of 100. You say, why is that? Well, I guess I don't want to get into this story right now, because we're actually done with this exercise, because we can get this x found by dividing both sides by ln of 3. And notice that this is same as x because we cancel this stuff, right? And that's exactly what we have produced right away. So that change of base formula, again, I could work out using the definition of logarithm again. So we can do this, but I guess, well, I don't think I want to waste time on this right now. We do this in very detail in college algebra class and intermediate algebra class as well. If you took any math, I'm sure you saw this stuff. I just want to refresh your memories, and I don't want you to memorize these formulas. I just want to show you those. They're all nicely gathered in this section. So today is basically just a review day of what you have learned, I hope, in the previous classes. And if not, it's fine because you could just learn it right now. So these formulas they put together in the beginning, so I can show you that. Change of base formula. Here it is. So you can put ln of C base is B, it goes to denominator. A goes to numerator, and you have ln over ln. So this is a very popular formula in math. So x is, yeah, you can actually find what it is. That's a good idea. So you can go to the calculator and also find it. So you say ln of 100. Let's put this in correctly. So I need to go back to main, put 100 in this parentheses, right? And then I want to divide this by ln of 3. So I need to go back again to functions, click ln, go back to main, right? And then put 3. And I get some kind of answer. So make sure that you use parentheses heavily because whatever comes out will be some nasty looking decimal. That's why people prefer not to worry about that. So if you want to get the answer, then you can get the answer. But I would rather just keep a fraction. But indeed, this is all designed in order to produce those answers. In other words, the power is a little bit more than 4. It's power of what? Power to raise 3 to get 100. Notice that 3 to the power of 4 is 9 times 9 is 81. See, it's already pretty close to 100. So you should have a little bit more. And a little bit more turns out is like 1/9 some. So there is no way you can check this without a calculator. So I guess that's the idea. So anyways, let me go back to this textbook and it's here. And show you another few formulas for the logarithms that come out from the exponents. And we already saw these two, this same basis, right? That disappear, all you get is x out. And same here, x gets out. There are 2 more popular formulas, and I'm not sure if they show them here. 2 more in the beginning of this. Yeah, here they are. They work for any base logarithms, so they don't really separate them with ln's or anything else. But you can see they called logarithmic rules, and sometimes solving equations we are using these rules, especially rule number such a product rule and a quotient rule. So they have them here. So if you have a product of 2 letters, then you separate this with a sum of logarithms. And if you have a difference of logarithms, then you get a quotient. I think I should do the exercise rather than just say it because it's kind of hard to comprehend this if you didn't see them for a while. So I think I will actually go back to the exercises and illustrate those 2 formulas, because I think today it's a good idea to just refresh memories on this story, especially if you never saw this before, then it's a good idea to not hurry with that stuff. So maybe I'll solve equation like problem number 21 to start. It'd be something kind of analogous to very first problem I did today, solve little equation. But now the problem here is that 53 is not a friend of 4, because in the previous section we had like 16, which is 4 squared, so everything was pretty straightforward. But now it's 53. I say, how come it's 53? Well, I erased it. I want to give it a little room here so we can do something. So 4 to the power of x is equal to 53. So it turns out that I need to find x, because I always have to find x, unknown, right? So what people do is apply lns on both sides, and that's what I actually just did when I tried to justify the process here. So they can bring x in front as a factor, so x times ln of 4 will be ln of 53. So I'm doing the exact same procedure that I just did in the previous example, and I get a quotient of ln of 53 over ln of 4. So again, I don't want to put this in a calculator. It'd be just my answer for x, and people leave it like that, and that's it. So we found x. How about 22? Well, here I can rewrite this without the logarithm. So base is 2, and this whole thing 4 is a power, and the result is x. So 2 to the power of 4 is 16, right? And that's it. So it looks like that one you don't need a calculator, because you could just use definition of logarithm. It's pretty neat. So sometimes you don't need the definition, sometimes you do need it. So let me try exercise like number 30 to illustrate those formulas that I just mentioned that need to be illustrated here. So in this exercise 30, it's interesting, it moves. They just updated my Zoom, the Bill Gates and Company, Windows. I had no choice but do the new version of Windows, and it updated my Zoom automatically. And now I have this little bit different layout. Do I like it? I guess I don't care, but I'm not sure why they do this, spend so much funds, right, on that stuff to just update and put the bar on the other side instead of remember it was in the middle, but now it's on the left side. Well, whatever. So anyways, what I want to do is put the logarithms together, because that minus means we're going to be dividing something. I don't think I wrote it correctly. It's ln of x. So the powers are on the way, so I need to use the power rule to bring them to the powers, because I want to have just single logarithms. So what I want to do is to write the 3 ln of x as ln of x cubed, and minus ln x to the power of 1/2. Or you can say it's a square root of x. So why I want to do this? It's because now we can say that this is a single logarithm of x cubed divided by square root of x, or x to the power of 1/2. See, whenever you have a difference of two logarithms, it boils down to a single logarithm. So I guess I'm going to continue this on the right side. And then we're going to, well, simplify this. So we get just letter x here, so we'll be able to find what it is. So I can say that 5, or I can say equals to 5 on the other side. Doesn't matter on what side the number is. And then ln of x to the power of 3 minus 1/2, isn't it? Because when we divide, we subtract powers. So that'd be a power of 2.5, basically. Or what the or 5/2, whatever. So now, since this is ln, I can get rid of ln, and that's the whole point, not to have these little ln's. That's what bothered me. So when I have single ln, I can say e to the power of 5 base, and the whole logarithm is a power, right? So I put it to the power is equal to x to the power. Now, how can I better put 5/2? Maybe I put 5 over 2, something like that, right? Because I need to get x. How do I get x? Well, the power needs to be 1. So how do I get power of 1? Well, turns out I can raise it to the power of 2/5. 5/2, 2/5, when they multiply, 5 and 5 will cancel, and 2 and 2 will cancel. So I need to raise both sides to the power of 2/5. And then this way, 5 and 5 will cancel, so it'll be just e squared. I selected one of the least pleasant problems in here. So I think it'd be a good idea if you look at that maybe outside of class over weekend and see all these little steps. If you can follow them, it'd be great. If not, it's fine, because I don't plan to ask you the nastiest problems on the exams, of course. You probably noticed that. I try to give you nice problems. So I'd like to do another exercise, and then maybe have you try to do one analogous to something nice. So what one can say, Alex, what do you consider nice in here? Well, maybe I can just do one similar to what I did before. So like logarithm base 3 of 9. What is that? Well, that's 2, because 3 squared is 9. People say as 3 squared is 9. So pure definition of logarithm. So 2 is a power. I raise my base to get 9. So can you analogously tell me what's the logarithm base 3 of 27 is? So that will be our little quiz for today. So look at what I just did here and do the same thing there. So tell what power of 3 is 27. That'll be our little quiz for today. Don't hurry. Main idea is not to hurry. Right? Little quiz.